Okay, here in our third video for completing the square, we're going to look at the situation where a is not equal to 1 or if b is an odd number. Now, nothing really changes here. We still have to be in the form x squared plus bx equals c to complete the square. So when we look at our example here, there are two things that have to happen before we can start solving this problem. One, we still need to move the numeric term to the right side by subtracting 2 from both sides, which would give us 2x squared minus 5x equals negative 2. Now, where we run into an issue is that we're still not ready to start because we still do not have a 1 in front of x squared, and we have to have a 1 in front of x squared. So the only way we can turn 2 into 1 is by dividing it by 2. And if we divide the first term of our trinomial by 2, we have to divide everything by 2, which unfortunately for us means we are dealing with x squared minus 5 halves x equals negative 1. Now that really doesn't change much other than making the values harder to work with. We are still going to insert a blank on each side and complete a trinomial that factors into a binomial squared. Okay, so we still have the same situation, the same exact approach. We're going to take that b value, whatever it is, in this case it is a fraction, it is the fraction negative 5 halves, and we are going to divide that fraction by 2. When you divide a fraction by 2, that is the same as multiplying the denominator by 2. So negative 5 halves divided by 2 is negative 5 fourths. We are then going to square that value, exactly the same process that we've done before. When you square a fraction, that is the same as squaring the top and squaring the bottom. So when we square 5 over 4, that would be 25 over 16. Again, it will still be positive because when you square a negative number, it becomes positive. We're going to add the same amount, 25 over 16, to the right side of the equation as well. And then we need to combine these like terms. Now, in order to combine fractions, we have to get a common denominator. So we're going to rewrite negative 1 as negative 16 over 16, and to that we are going to add 25 over 16. So negative 16 over 16 is negative 1 plus 25 over 16. We would then add the numerators, which would give us 9/16. Nothing else in this process changes. Our next step is still to take the square root of each side. So we have the square root of quantity x minus 5 fourths squared equals the square root of 9/16. Just like before, on the right side, all that happens is the exponent cancels with the root, leaving what's inside the parentheses, x minus 5 fourths. On the right side, when you take the square root of a fraction, that is the same as taking the square root of the numerator and the square root of the denominator. So the square root of 9 over 16 is the square root of 9 over the square root of 16, or plus or minus 3 fourths. We would then add 5 fourths to each side of the equation to get x by itself. I'm going to move up here into space. Shows us that we have x equals 5 fourths plus or minus 3 fourths. There is absolutely no reason why we cannot add those together. So we have 5 fourths plus 3 fourths for one answer, and 5 fourths minus 3 fourths for the other answer. Keep in mind that whatever values we get here, on the top we're getting 8 fourths, has to be reduced to equal 2. So our first answer is x equals 2. On the second problem, we do 5 fourths minus 3 fourths, which is 2 fourths. That reduces as well to 1/2. So our answers would be x equals 2 and x equals 1/2. Let's do another one. So here we have another example, 3x squared plus 4 equals negative 8x. Once again, it is not in the correct format. We need to move the numeric number to one side, and we need the x terms on the same side. So we need to move the 8x to the left and the 4 to the right. This will give us 3x squared plus 8x equals negative 4. In addition, we need that 1 in front of x squared. So we do have to divide everything by 3. So when we get to the point where we're ready to start completing a square, we are working with x squared plus 8/3 x equals negative 4/3. We're then going to insert our blanks. So again, it's the same exact process on every single example, no matter how ugly the numbers are. We take the b value, which in this case is 8/3, and we divide by 2. Remember, I said that means we multiply the denominator by 2. So when we divide 8/3 by 2, that would be 8/6, which reduces to 4/3. So 8/3 divided by 2 would be 4/3. We are then going to square that value. So 4/3 squared would be 16/9. We copy that value onto the right side. So we have negative 4/3 plus 16/9. We need a common denominator, which would be 9. So we multiply the bottom and the top by 3, and that gives us negative 12/9 plus 16/9. Add those together, negative 12 plus 16 would be 4/9. We then take the square root of each side, so the square root of quantity x plus 4/3 squared equals the square root of 4/9. Again, on the right side, all that happens is the parentheses and the exponent will cancel with the root. On the right side, we take the square root of the top and the square root of the bottom, which would be 2/3. Final step then is to subtract 4/3 from each side of the equation, which gives us x equals, I'm going to move up here again where there's a little bit more room to finish the problem. X equals negative 4/3 plus or minus 2/3. Again, there's absolutely no reason why those cannot be combined. So we have negative 4/3 plus 2/3 and negative 4/3 minus 2/3. That would be negative 2/3, which is our final answer there, and negative 6/3, which would be negative 2. So our answers are x equals negative 2/3 and x equals negative 2. So that's how we deal with a situation where a is not equal to 1 or where b is odd. It just means we're going to end up with fractions in the process. The process is still the same every single time. One more video where we're going to connect this to the quadratic formula.